All right, so this is for worksheet 13.2, part 2. And best thing here, might have got you a little nervous on the first video, but don't panic. Okay, hey, don't do that. This is actually fairly easy. Stuff you already know. You just put it into a vector format. So let's start back in terms of Calc 1 here. Actually, pre-calc, I think we did definition of a limit. So remember steps 3 on this here, when you have like the limit as x approaches a on the left side of f of x, and then let's say it goes some limit of L. You have the limit as x goes to a on the right side of f of x, went to the L, therefore step 3, the limit as x goes to a of f of x. So if the left and right are the same thing, that means you have a limit of L. And therefore we did a conclusion that, so on the conclusion, if those three things are true, then f of t has a limit at t equals a. Okay? So now that we are doing, to start off here, finding limits of vector value functions, it's the same thing. Same thing for two-dimensional or three-dimensional. Okay, and for vectors, it's the same thing. So basically, let's just throw in the notation out here. So if I say find the limit as t goes to, and notice this is not a numeric value, but as a time, let's say t goes to t 1, when, say r of t, and now this is not a line anymore, it's a function of values per terms of x and y and z. Okay, so keep that straight in terms of what you are working with. So that part you have to be kind of careful of. So we have a function of x of t, a function of y of t, and a function of z of t. So basically, if I ask you to find that limit here, so what's the limit as t goes to t1 of rt? Well, basically, you're just doing the limit of each piece here. So what's the limit as t goes to t1 of my x function? What's the limit as t goes to t1 of my y function? And likewise, the last one, your z, like so. So basically, you're just doing the limit, but you just do it 3 times instead of, like in Calc 1, you just did it 1 time. So again, most of the time, coming back here, a lot of times we just did the plug and chug. So remember, the basic rules: plug and chug. Plug your values in, find the limits, and take it from there. You get a sticky bottom. Try finding ways to get rid of your sticky bottom and find the limit that way. Okay. For the most part, they're going to be fairly simple, so you don't have to really worry about too many difficult problems like you did in Calc 1. Okay. All right. So let's do an example. All right. So I want you to find, say, the limit as t goes to 3 of rt. Okay, when rt has the function, so t squared, 1 minus t, and t to negative 1. Okay, so the notation here, we will be saying what's the limit as t goes to 3 of RT. And basically you're just doing, and notice there's no real sticky bottom here, so if you just do a plug and chug. Okay, so like here you got 9, here what's my -2, and 1/3, and that's all you're doing. Okay, so like I said, don't panic, fairly easy, all that, which then leads us into, now let's do derivatives. So let's look at a limit derivative. And that we did way back when. So if I did, let's say d dx of f of x, that would be doing a limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so if I do a vector value function, does it change anything in terms of what I'm doing? So if I say, okay, other than my notation, it'd be d dr of rt, and basically you're going to be doing each limit by itself. So this would be the limit as h goes to 0, but it'd be r of t plus h minus r of t over h. And basically you do the derivative of each component as itself. So let's use simple notation now. Let's use Euler's notation. So if I say d dr of rt, okay, which would mean that this is r prime of t, which means you're just doing the derivative of each component, just like a limit. So you have x prime of t, y prime of t, and z prime of t. Okay, but again, remember, r is not considered a line, but a vector value function. So each component is some form of a function. That's all it is. So no different than we've been doing. So as an example here, so if I say d dt of t squared, t cubed, and sine of t, that would mean you just do the derivative of each one. So 2t, 3t squared, cosine of t, and you have it. Okay, pretty straightforward. Let's go in terms of doing multiple derivatives, because we're going to be looking for position, velocity, acceleration, and all that. So if I want you to do like this. Say find r double prime of 3 when rt equals ln of t, and t squared. Okay. So notice we're doing acceleration here. So r prime of t be 1 over t, comma 1, comma 2t. R double prime of t be negative 1 over t squared, comma 0, comma 2. Therefore, r double prime of 3 be negative 1/9, 0, and 2. And that's all that is. Okay. All right, so let's go to the derivative rules. Okay. So derivative rules. Okay, so if we do, say, derivatives of sums. Okay, so if I have, let's say, 2 vector value functions, so I'm going to do d dt of r1 t, I should call it t1, plus, yeah, it's got to be at the same time, plus R2 of T1, so it has to be the same thing. So basically, this would be R prime of 1 plus R prime of 2, like so. All right, constant. Okay, doing derivative of constant, remember it just goes along for the ride. So if you have some constant on the outside of RT, okay, constant just goes along for the ride. You have R prime of T. Okay, product rule. Okay. Okay, so if you have d dt of, and let's put two functions together here, and oops, rt, that's an r there. Okay, so same thing, I'll put it down here. So you have f prime of t, derivative of the first times the second, plus derivative of the second times the first. Okay, now there will be a little trick here to try to keep this straight, because this is going to be kind of confusing because you're dealing with vectors there, and keep them in the right order. One more rule, I'll come back to that one in a second here. Let's do the last rule here, chain rule. And you have, let's say, d dt of r of g of t. So you got to do the derivative of r first, and then times it by the chain piece g prime of t. And you'll definitely need some examples of how that works. So let's come back to the product rule, because I think you need some example of how to set up a format so you don't make mistakes on those. Okay, so product rule, let's say you have RT, and then let's say we have t squared 5t1, and let's say f of t equals e to 3t. So what we're trying to do here is doing the derivative of ddt of rt times f of t. So remember, this is again r prime of t times f of t plus f prime of t r of t. So the best way to keep this straight is keep them underneath each other. So let's go r prime of t. So this would be 2t 5 and 0, f prime of t, oops, second, I just did one value, so therefore it's 3e of 3t. So best way to do this is this thing is like a cross product, but the only thing is you're adding them together, you're not subtracting. So kind of like a matrix. Okay, so the first piece here, and notice it, since it's addition, it doesn't matter which way you go. So we'll do this diagonal first. So that would be then e to 3t times 2t 5 and 0 plus, now this one here, 3e to 3t, and you got t squared comma 5t comma 1. Okay, and now you can keep life a little bit simple here. You can pull out various kind of factors if you want. Like for example, I can pull this out, and because I do have to finish adding these here. So basically I'm going to be, my x components will be 2t plus 3t squared. What's that? 5 plus 15t and 3, like so. Okay. All right. So let's do chain piece here. So let's say we have Can we see those functions up there? Yeah, I'll leave it there. Okay, so let's say d dr of r of f of t. And going back to that there. Okay, so basically this would be r prime of f of t times f prime of t. So what we got to do first is r prime. So let's figure that out. So r prime, and I got that right here, would be 2t, 5, 0. Now let's finish that out. So now what I have to do is take my f of t and plug it into any t. Let me change colors here. So I only have one t here. So therefore, this would be 2e to the 3t, 5, 0. Okay, so hopefully that makes sense. Now times it by the derivative of f prime of t, and therefore that's that piece there. So I have 3e to the 3t. Okay, so hopefully that makes sense of what I did here. Remember, I just found r prime of t, and then plugged in f of t after that. All right, so now let's go to dot and cross and derivatives of those. Okay, so again, don't panic. It's pretty simple. Okay, so derivatives of dot and cross products. Okay, so dot is basically the same thing as multiplication here, d dt. So if you have r1, t1, and now I'm going to change this because now we're dealing with a different time frame, r2, t2, but it's the same thing as the product rule. So r1 prime of t1 times r2, t2 plus, plus, I hope I can get this in, r1 t1 times r prime 2 t2. Squeeze it in. Okay, so let's do an example of that. So let's say r1 of t, and I'm just going to do, let's say, two-dimensional here, make it a little bit easier. 3t, t squared, and say r2 t, and say 4t, 6t squared. And I'm going to keep it simple. I'm going to use the same time here for right now. So derivatives, so r prime of 1, that would be 3t squared, and with 2t, r2 prime t, and like I said, I'm going to keep the same time here. And basically, we'll do the same thing as before. So product rule of this, but now remember we're doing a dot product. Okay, so we're going to be adding these values together. All right, so the dot product here would be 4t cubed plus, is that 12t cubed? Okay, so here is now the other cross piece. So now we have 12t cubed plus 12t cubed. And if we add all those up, I do believe it's 40t cubed. Okay, a little bit different than the other one because we're leaving it as a vector. Here we're doing a dot, and remember, anytime you do a dot, you get a single numerical value. All right, let's do a cross product. Okay, so So d dt, and we have r1t cross r2t. So it's kind of like the product rule here. We're going to be doing r1, and we're going to leave the times out here, cross r2 prime plus r prime 1 cross r2. So it's like a product rule. But now remember, this order matters here. So this is first. Notice it's first and first. You can't switch those around. Okay, so let's come back to, I suppose, previous problem here. I had r1t, t cubed, t squared. And say r2, we had 4t, 6t squared. And we got the derivatives of these. 3t squared, 2t, and r prime 2, 4, and was 12t. Okay, now there's some different ways of doing this. So since we are just in 2D here, not 3D, I'm still going to treat it like a 3D. So since we're doing this first one here, let me change my color here. Doing this one here. Okay, so we're doing the cross of these two here. So let's set it up. I hat, j hat, and k hat. And what we can do here is, now order matters, so we have to go t cubed, t squared, and then I put here 4 and 12t, and then just put zeros here. So basically, by setting this up, you're only doing the k component only, because all the other ones will give you zeros. So doing just this one here, I get 12t to the 4th minus 4t squared. Okay, now we're going to be adding that to the other one here. So let's do that. So now let me change my color here. So now doing this one here. So I hat, j hat, k hat. Okay, order matters here, so we got to make sure we do the right one first. So we have to put 3t squared, 2t, and 0. Okay, and then 4t, 6t squared, and 0. Okay, and then again, we're doing the k component, which means we're going to be able to add all these up. So this one here gives me 18t to the 4th. Got something wrong there. I think 3t squared, 2t, 4t. Is that right? I get something different than on my answers here, but I'm going to keep going with it. Let me just double check everything here. I'm going to keep going here. So minus 8t squared. And therefore, you have on the fourths here, looks like 30t to the 4th minus 12t squared. Okay. Something doesn't look quite right there, but hopefully I don't see what I might have done wrong. But anyway, everything looks good. Okay, but at least you got the idea of it. Let's do a three-dimensional one. So therefore, say R1, t squared, t and 1, R2, You have 4t, 5, and 3t squared. So let's do derivative, our prime of 1, 2t, 1, 0. Our 2 prime would be 4, 0, 6t. So set it up, and my first one here, doing the derivative of this one, let me change colors here. Okay, so that one would be I hat, J hat, K hat. Okay, and I got to start with that one there. So I have 2t, 1, and 0. And then 4t, 5, and 3t squared. And just say sometimes, so if you go through this, you should get 3t squared, negative 6t cubed, and 6t. Okay, now let's do this diagonal. Again, you got to start with this value first. Okay, so you have I hat, J hat, K hat. So t squared, t and 1, and then 4, 0, and 6t. And that component, you should get 6t squared, 6t cubed minus 4, and negative 4t. Now add those together, and now you add in, since this is a three-dimensional, you don't get a single numerical value. So what you have here is 18t, excuse me, we're adding 9t squared. What does that give me? Looks like just negative 4, and gives me 2t. And there you go. That's it. Nothing too bad. Okay, of course, then if we do a derivative, you have to be able to do the antiderivative. So again, don't panic. Same thing, except you're just doing 3 things. So let's say if you have the derivative, dr dt is given to you, and my function is, and let's do a 2-dimensional, 4 plus 6t, 9t squared. And let's say my initial condition are 0, so notice my initial condition, my time is 0, I'm at 3, 1. So therefore, my r of t would be, now do the antiderivative of each individual piece. You have 4t plus 3t squared, comma, is that 3t cubed? But you have a constant for each one of those. So let's break down into components. So my x component is 4t plus 3t squared plus some constant. Well, at time 0, my x component is 3. So therefore, this would be 3, and my time is 0 plus c, so c is 3. Likewise, my y component is 3t cubed plus some constant. So at time 0, my y component is 1. So 1 equals c. So put all this back together. So my x component, 4t plus 3t squared plus 3. And my y component would be 3t cubed plus 1. Like so. So again, nothing new, just looking at it in terms of components. Instead of doing it once, you're doing it twice. This was 3-dimensional, you do it one more time. All right, that is it for this